Hello there, welcome to Mathematics Learn Extra. I'm Mark Ancelotti, and today I'm going to be taking you through a revision session, grade 12, analytical or coordinate geometry. Just to let you know that this show will be broken up into two segments. So the first segment is going to be the analytical or coordinate geometry involving lines, and our later show that you'll get at another time is going to involve circles. I also need to let you know that we're going to be doing a number of past paper questions, so these are all important matric revision sessions, and all of the questions are at the level of your matric examination. So pay attention, hopefully you're going to be learning something new. Let's look at our first question. Our first question comes from the November 2011 paper 2, and we're looking at question 5. Now, of course, whenever we approach any question, it is so important to read the information very, very carefully and to ensure that you take that information and transfer it to your diagram if necessary. So let's read. They tell me that Pqrs is a rectangle. Straight away I know that all of the interior angles are 90 degrees, and that may be important when I solve later on. They also make mention of the vertices. So I've got vertex minus 4, 0 at P. I've got 4A. Straight away I'm seeing an unknown, so I know that I'm going to probably have to get to that at some stage. R is 6, 0, and I don't have S. All right. They've also told me that Q is in the first quadrant, which is immediately telling me that this A over here is going to be positive. So that's important if I have to go and solve it. And there we go. The very first question says to me, show that A is equal to 4. Now, for all of you at home, I just want to bring something to your attention here. Whenever the question says show that, the question could very easily have said solve for A. But if it says show, that is the examiner's way of saying that particular value will be used later on. So if you cannot get that first one, and we hope that you are going to get it right, if you cannot, then take A is equal to 4, and you can use it in part 2 and 3 and all the questions that follow. Remember, that's a very important exam trick or technique. Now, they tell me show that A is equal to 4. I look at my diagram, and the thing that really jumps out is that I've got this 90 degree. And that 90 degree tells me that I'm linking gradients. So I'm going to start off, and I'm going to find the gradient of PQ. Now, you will get this in the exam. You'll find that sometimes the very first question is relatively straightforward. So I'm going to find the gradient of PQ. I'm just going to make sure that I've got that coordinate. So I'm going to do the change in y, y1 minus y2. So I'm going to get A minus 0. And then I'm going to go do the change in x, and that's going to be 4 minus negative 4. And so what I'm going to get over here is I'm going to get A over 8. So that is the first gradient. I'm now going to look at the gradient of the other line segment over here. Okay, this QR. And so I'm going to do exactly the same thing, and then I'll link and see what I get. So I'm going to now find the gradient of QR. So remember, I'll go and say the change in y. For me, because I know that I'm solving for A, I'm making A the subject of the formula. Instead of going randomly, I'm always going from the A. So I'm going to now go A minus 0 over 4 minus 6. Okay, and so what I'm going to get here is A over negative 2. So I've got one gradient over there. That's the gradient of PQ. I've got the other gradient. Now, when we are going to go and solve for an unknown, you know from grade 8, if you've ever got to solve for an unknown, you need an equation. And so you have to say to yourself, how can I create an equation so I can go and solve for an unknown? And the answer to that question lies in your diagram. So let's go back and look at the diagram, and we see that there is a right angle. That right angle tells me that we're linking the gradients. And if you go to your matric formula sheet, it'll tell me that if you've got two perpendicular gradients, then M1 times M2 is equal to negative 1. And so I know then that the product of the two gradients that I've created, because they lie on the right angle, that product is negative 1. And that's going to enable me to go and create my equation. So I know that A over 8 multiplied by A over negative 2 is equal to negative 1. And because we have perpendicular gradients. Now, there are many other ways in which you could have used this concept to solve for A, but I think I'm going with the more traditional approach. So what I'm now going to do is I'm going to go and solve for a. So I'm going to multiply across a times a is going to give me that a squared. The negative 2 times the 8 is going to be negative 16. That answer is going to be negative 1. And so when I go and solve and I cross multiply, I'm going to get a squared is equal to 16. Now you could use your knowledge of quadratics, but you can also just straight away say to yourself, well, a would then be plus or minus 4, because I'm going to square root both sides. Now, many of us would stop there because we've solved algebraically and we solved beautifully. But there was one little proviso. In the initial question, they said to me that A is in the first quadrant. If I just go back to my diagram, what you will see here is that they say that the point Q, which involves that A, is in the first quadrant, which then tells me that all of these A values are positive. And so I'd have to reject that little negative solution. And so therefore, A is equal to 4. Okay, so that's part 1 done. And my advice to you is when you go to part 2, transfer that into your diagram straight away, because you're going to be working from the diagram throughout. Make sure that information is on your diagram. So let's go to part 2. I've got exactly the same diagram, but I'm reminding myself that that A was now equal to 4. So let's see what part 2 says. It says, determine the equation of the straight line passing through the points S and R. So I'm going through S and R. In the form of y equals mx plus c. Well, in the initial question, they said to me it's a rectangle. And a rectangle tells me that the opposite sides are parallel. And because they're parallel, it means that the gradients are the same. So I've already worked out the gradient of PQ. So if you don't mind, I'm going to need to jump to the previous page. So the gradient of PQ on the previous page, if I just go down, what was PQ? PQ was A over 8. All right, so I know that from part 1, the gradient of PQ is A over 8. But the nice thing now is that we know the value of A. Either I've worked it out beautifully or it's been given to me by the examiner. And so because A was equal to 4, I now know that this gradient is 4 over 8, which is now equal to a half. Now I must conclude, because I knew that this line, PQ, had a gradient of a half, but SR is parallel, and so now I know, therefore, the gradient of SR would be equal to a half because we've got parallel lines. And it's nice to just put some kind of documentation for the examiner so they know where that has come from. So because we're finding the equation of a straight line, we know it's of the form y equals mx, and I've got this mx plus c. To find c, you need to sub in some point that is going to be on this line. So we go back and say, is there any point that is on the line SR that is given to me? And of course it is. We've got this point R. And that is given to me, and so I can substitute it in to find the equation of the straight line. So remember, you're not just subbing in any particular point. You're trying to find a point that is on the line that you're trying to find. And that is the way that you always solve for the final unknown of your equation. So I'm going to be putting in the point 6, 0, which is my point R. And then I'll go and solve. Now, there are many different ways in which teachers will teach solving the equation of the straight line. Some will use y minus y1 as m times x minus x1. I'm just going to substitute the point into this basic form of the equation. So y is 0. X is going to be 6. And then I'll just go and solve for c. So half of 6 is 3. And when I take it over, I've got negative 3 is equal to c. Please don't think that you are finished, because the examiner asked for the equation of the full straight line, and so I must give the full equation. And so therefore, y is equal to half x minus 3, and I'm going to tell the examiner this is the equation of line SR. Okay, and so now I've got that equation. Very important. Remember to answer the question clearly. Ensure that you have given the examiner the full answer. Let's go to part 3, and we'll see where part 3 is taking us. And part 3 asks us to find the equation, to find the coordinates of S. Now, S is this little point just on the far side of your rectangle. So there are a number of ways in which we can approach this, and I think in this show I'm going to look at 2 different ways because they're both equally good. So I'm going to look at the diagram, and I know because I have a rigid shape, because I have a rectangle, if I'm going from Q to R, I'm going in exactly the same way as I would be going from P to S. And we've encountered that also in paper 2, where we talk about transformations. And so if you are moving a point from one place to another place, we refer to that as a translation, and you've come across that many times. So I want to talk about the rule where I go from Q to R, and I'm going to talk about translations. So let's look at this diagram here. I'm going to move from Q to R. If I'm moving Q to R, I know that I'm going in a very specific way. So if I go across, I'd say to myself, well, how far across did I go? I'm going across 2 units. And then I'm also going down. Okay, so remember that this point was 4 for A. We found that in part 1. Then I'm going from 4 down to 0, so I'm going down 4 units. If I'm going from P to S, surely it's going to be exactly the same rule. It's going to be exactly the same translation, because each point is formed in exactly the same way. And so I'm going to try and document this so that we can see the rule that I'm talking about. I'm going from P to S. I know what P is. I don't know what S is, but I'm going from Q to R, and I can see what the rule is. So let's talk a little bit about that rule. All right. So the rule, and remember how we write a rule. So I'm going Q to R. And I would see that x, y is going to map onto. Now, each and every x is going 2 to the right. So I'm going to say, well, that would be x plus 2. And then the y's, well, I'm going from 4 to 0. And so each y is going down 4 units. And so all that I would do is I would apply this rule to now go and find S. So to go and find S, I know that I'm taking point P and I'm applying the rule. And so I know that my new coordinate for S is now going to be minus 4 plus 2. And the y part, which is 0 minus 4. And so when I just go and simplify that, I'm going to get negative 2, negative 4. And that then would be the coordinate for S. Now, sometimes this method is actually very easy, but it's quite difficult to document it. And from my experience, most examiners are giving you full marks for the final answer, and you just need to give some kind of explanation. Let them know that you're doing a translation, or some teachers will talk about a vector movement. But you are transforming each point in the same way by realizing that all the points in a rectangle are formed by the same rule when we move across. I'm now going to approach this question in a different way, which is probably what most people would do, and that's to use the properties of quadrilaterals. So let's look at this again, and I'm going to do it, but I'm going to do it in a different way, and we should arrive at exactly the same answer. So now, I've got this rectangle, and I'm trying to find the coordinates for S. What I know is that if I've got a rectangle or parallelogram, the diagonals, okay, are going to bisect each other. So let's just go. If I've got this diagonal there, and if I've got that diagonal there, the diagonals will bisect each other, which will mean that they're going to share the same midpoint. So this over there and that over there are going to be true for all palms, which is a rectangle, a square, a rhombus. This property is true. So what I know is that the midpoint of PR is going to be the midpoint of QS. And so I'm going to use my knowledge of midpoints and go and solve. And we know that the midpoint formula is not really complicated. It's just really finding the average of the outer points to get to the middle point. And remember that that formula is given on the metric formula sheet. So I have been given points P and R. So those are definitely given. So what I'm going to do is I'm going to try and find the midpoint of PR, which is also the midpoint of QS. So let's go, the midpoint of PR. And so what I would do is I'd add the outer x's, so it's minus 4 plus 6. And many of you would say, oh, Mark, don't go this long way. It's so simple, it's on a horizontal line. But I'm just going through the formula and making sure that we're comfortable with that. So it's minus 4 plus 6. Over 2. Remember, it's x1 plus x2 over 2. And then it would be y1 plus y2 over 2. I would not normally show that, but we can see that along this horizontal line, the y's are both 0. And so then I'm going to go and work that out. Minus 4 plus 6 is 2 over 2. and 2 over 2 is 1, and 0 over 2 is 0. And so now I know the midpoint of PR, okay, is going to be the point 1, 0. So I'm going to use this knowledge and say to myself, well, the midpoint of QS would be the same midpoint because the diagonals of a parallelogram and a rectangle are going to bisect each other. And so I'm just using the fact that I know the middle, and then I'm going to go and solve for points S, X, Y. So let's go. So the midpoint of SQ, look what I'm going to do. So the midpoint of SQ is going to be 1, 0. I already know it from above. But now I'm going to go and create my equation. So the midpoint of SQ would be add the outer x's together. So it's going to be x plus 4 divided by 2. And then I add the outer y's, which is y plus 4 divided by 2. So x plus 4 divided by 2, y plus 4 divided by 2. And now I've created my equation. So remember, if you're going to try and solve for any unknown in any branch of mathematics, you're always trying to create an equation. And so you say to yourself, what rules do I have? What do I know that's specific to the section of mathematics so I can create my equation and then I can solve for my unknown? And so here from the midpoint, I'm going to take my x independently because it is an independent part of the formula, take my y independently and solve for them separately, and then I'll get my x and y. Okay, so what I do know is that x plus 4 over 2 had to give me an answer of 1. I can cross multiply. X plus 4 is then equal to 2. And so then my x is equal to minus 2. It's going to be 2 minus 4. And then I'm going to go and solve for my y. And I also know that, well, the y component had to give me a 0. So when I cross multiply by the 2, it's still 0. And so I get y plus 4 is 0. And then y is equal to negative 4. Please remember to answer the question. The examiner said to me, find the coordinates of S. So I must give the full coordinate, which will then be negative 2, negative 4. And what we notice is that for this method, which is more traditional, where I'm going to be using the knowledge of the midpoints, and the other method where I'm playing with this knowledge of translations, I'm getting identically the same answer. They're both equally good, and there are many different ways where you're going to solve simultaneously where you can still arrive at that point. So if you were trying this at home and you did a different method, just check the answer and ensure that you're getting the right answer and that your method is valid. All right, I think there is another part to this, so let's see where we're going. There is part 4, which is now saying to me, calculate the length of PR. Okay, that really is very straightforward. And if you don't mind at home, I'm not going to use the distance formula, because if I have a horizontal line, or if I just have a vertical line, to find the distance, I'm either finding the difference between the x's or the difference between the y's. So later on in the show, I promise we will get to distance formula. I'll do it in the traditional way, where we take the distance formula equation from your formula sheet. But for here, it's very straightforward. The distance is going to be the change in the x's, which will be 6 minus negative 4, which is 10. Or you could have at home just said, you know what, that distance, I don't mind the fact that I'm going in a negative direction, that distance is still 4 units. This distance over here is 6 units. Together, that's going to give me 10 units. That's 2 marks that are a bank in your exam. You really want to come across that kind of question. And then let's go to my next question. And over here, which is the final question, okay, of this particular, or the final part of this first question, is quite wordy. So I'm going to try and understand what's going on before I go and answer it. So it says rectangle PQRS undergoes the transformation x plus k, y plus l. Now, for those of you at home, this should not be now unfamiliar, because during my solution, I've encountered or come across a translation. That is a translation. Remember, translation just takes a point and it moves it somewhere to another point on the Cartesian plane. It doesn't rotate, reflect, or do anything else to it, but it just merely moves it. And so what we're doing is we're saying we're moving this rectangle in a certain way according to a rule, where I'm moving the x's, and that would be the x of every point, and I'm moving the y's. So let's understand a little bit more. So it says that we are going to transform x, y, each point of the rectangle, in the following way: x plus k, y plus l, where k and l are numbers. Okay, so that just means that I'm moving in a certain way. Now here's where I've got to read carefully. What is the minimum value of K plus L so that the image of Pqrs lies in the first quadrant? Okay, so I'm starting to understand, and what you've got to do is you've got to read. There is definitely an explicit question. They are saying to me, what is the minimum value of K plus L? So when I answer right at the end, I'm going to say the minimum value of K plus L is 10 or 12 or 20 or whatever the answer and the information is telling me. So you must answer what is the minimum value of K plus L. But I'm now going to interpret what I'm really doing, because until you interpret, you can't answer the question. So they are telling me that I want the entire image of Pqrs to be inside this first quadrant. So really, I'm kind of like shifting everything across in that direction. So I'm going to shift it right, I'm going to shift it up, and I'm going to make sure that these points P and S are no longer outside. Now, it is important. I've solved for S, but I need to transfer that information onto my diagram, because that is very, very important. So I'm just trying to remember that it was -2, -4. So you could say a couple of things. You could say, okay, I know that for this particular S, maybe I want to move it 2 units across. But if I move it 2 units across so that I'm no longer to the left, this particular P is still totally out. So take the furthest left value. And I'll say to myself, well, the furthest left value has to move in at least 4 units so that nothing is sticking out to the left of the y-axis. Then I take my lowest value, and I say to myself, that has to move up a minimum of that number of values for y, that distance of y. So I'm moving it up a minimum of 4, so it no longer sticks below the x-axis. And so if I move it 4 units right and I move it 4 units up, then I know that neither P nor S are going to be outside of that first quadrant. Now let me see if I can try and write this in a meaningful way so that you can follow my method nicely. Okay, so what I'm going to do is I'm going to look at P, which is -4, 0. I know that I want to move it at least 4 units right. So when I'm doing that, oopsie, let me just clear that up over here. When I'm doing that, I know that I'm linking to the actual K value. So I know that I'm going to be looking at X plus 4. And this is talking about the minimum in terms of that transformation. So I know that K is going to be greater than or equal to 4. It can be more than 4, then I'm always in the first quadrant. But equal to 4 means that I'm going to be lying on the origin or on the boundary of that first quadrant. Then I'm also looking at the S part, which is -2, -4. And I know that I'm wanting to move up at least 4 units. And so when I'm looking at this actual transformation, I know this is the y plus L part, and so I knew that this was y plus 4. And it's just coincidental that they're both involving a 4. So I know then that the L is greater than or equal to 4. And so therefore, I know that K plus L must be greater than or equal to then 4 plus 4, which is going to be greater than or equal to 8. So then I know the minimum sum. So the minimum, let me just go back to the question so I make sure I answer it carefully. The minimum value of K plus L. All right. So the minimum value of K plus L is equal to 8. And we needed to realize that this was a minimum value. And so that now has effectively taken my rectangle and it's no longer outside of the first quadrant. Lovely question involving other aspects of paper 2. So don't always think that in the analytical coordinate geometry section you are just dealing with lines or circles. Some of the transformations will come in and sometimes even some trigonometry. But I think we've worked hard enough on this first question. We deserve a little break. So we're going to take a short break, and when we return, I'm going to tackle question 2. See you shortly. Hello there. Welcome back from the ad break. Let's dive straight into question 2. Question 2 says to us, in the diagram, PQRS is a quadrilateral with vertices 5, 2, Q1 -1, S9 0, and R9 -5. So we just make sure that those points are all reflected on our diagram. I'm also noticing this right angle, which is important, so let's continue to read. They tell me that PT is a perpendicular height of PQRS, and W is the midpoint of QR. That may be important later on, although I know we were pressed for time, so we haven't done the entire question too. So there's some piece of information in the diagram that we don't actually refer to in this question. Okay, so let's just see where they're taking me. First question, prove that PQRS is a trapezium. Now, whenever we're proving any one of the quadrilaterals, you must go back to what we refer to the analytical means. You know that you're going to be using either the distance, or you're going to be talking about the gradient, or even sometimes the midpoint. And so if I'm talking trapezium, before I even look at my diagram, I say to myself, what are the properties of a trapezium? At home, what are the properties of a trapezium? Well, you know that you just need one pair of parallel lines. You just need to show one side and its opposite side are parallel to each other. If it was a parallelogram, well, then we'd go through and show both pairs of both pairs of sides are parallel. So you know that you're dealing with possibly here the gradient, which I think is the easiest way. So if I'm talking about this being a trapezium, I can see very clearly that QP and SR would not be parallel. Even though the front cover of the exam says the diagram is not drawn to scale, that would be so totally misleading. I'm looking here at PS, and I'm looking at QR, and I'm going to compare their gradients. So that's not too difficult. So I'm going to go and look at the gradient of PS. So I don't have all the information. I'm going to have to keep scrolling up and down. I'm sorry about that. So the gradient of PS, change in Y, 2 minus 0. Okay. All over the change in X, which is 5 minus 9. And so what I'm going to get over here is 2 over -4, which is then -1/2. And then I'm going to go and find the gradient of the other line segment, because I'm trying to show they're parallel. So you can't use the fact that they're parallel. You can't say this has to be. You must go and do it independently. So I'm going to find the gradient of QR. Again, I go and say the change in Y, which is -1 minus -5. And go over the change in X, which is 1 minus 9. And so over here, I'm going to get minus, so it's -1 plus 5 all over -8. And so I'm going to get 4 over -8, which is -1/2. Beautiful. I've got the same gradients, so therefore I can conclude that I've got parallel lines. But remember, you're trying to prove that you've got a trapezium, so you must answer the question as clearly as possible and draw all the necessary conclusions. So what I would now say is, well, therefore, PS is parallel to QR. So I'm telling the examiner I now know they're parallel, and therefore PQRS is a trapezium. Okay, because I've got one pair of parallel lines. And that would be sufficient for full marks. I've drawn to the examiner's attention that there were parallel lines, which enables me to conclude that I have a trapezium. Now let's go to the second part of this question, and this is the final part of this question here. So what are they now telling me? They say, given that T has coordinates 3, -2. Well, don't wait for anyone to ask you. Go and put it on your diagram. So this would be 3, -2, because you're going to use it. The examiner's given it to you for a reason. Then they're saying show that QT is a third of TR. QT, well, when they're talking about a line segment, QT, we're actually talking about a length of that line segment, because I'm saying if this segment is a third of the whole, this part TR, well, then we're talking about distance. Now, I'm going to approach this using distance because I've got the coordinates of T, I've got Q, I've got R. But please remember, in the initial question, they said to me that W is a midpoint. I could possibly have found the relationship between T and W. I could have done all sorts of ratios of the line segments, doing something else a bit more creative. But right now, I'm wanting to look at the distance formula, and I want to do that properly. So take each of these independent pieces, and let's go and do it. So I'm finding the distance of QT. This is given on the metric formula sheet, so there are no excuses if you don't write that down properly. And we start off by saying the change in x, so it'll be 1 minus 3. Okay, 1 minus 3 all squared, plus then the change in y all squared. I'm going straight from the distance formula and the metric formula sheet. Change in y, so it's minus 1 minus negative 2. Now let's not go too quickly. So inside here, this is going to be negative 2 all squared plus, now let's work in here, minus 1 plus 2. Okay, so it's going to be minus 1 plus 2, which just gives me positive 1 all squared. And so then I'm going to get 4 plus 1, and this is the square root of 5. Okay, so I've found the distance of QT. Now I'm going to go and find the distance of TR and then make a comparison. All right, so I know I'm going to be doing the change in x all squared plus then the change in y all squared, and I just need to find those coordinates. So TR, there's TR. So the change in x is going to be 3 minus 9. And then the change in y is going to be negative 2 minus negative 5. Be careful when you've got those negative negatives. Okay, so negative 2 minus negative 5. And then I'm going to go and simplify that. And so inside, I'm going to see negative 6 all squared, plus then negative 2 plus 5 is going to be 3. And so I'm going to work out that I'm going to get 36 plus 9, which is then root 45. Now, if I put that on a calculator, that would simplify nicely. And so I'm just going to write this answer into simplest third form. 45 is the same as 9 times 5. Hopefully you remember that you're always trying to form the product of a perfect square and another number, because then I can square root the 9 nicely, and so this is 3 root 5. Now, I found the distances, and I would have got a fair amount of marks for my working so far. So I've created the distances. Now I want to go and answer the question. The question is specifically asking me to find a relationship between their distances, and I'll see what that says again. So it's saying to me, show that QT is a third of TR. So I'm going to look at the relationship between QT and TR. So let's take the distance, QT, and let's look at the distance, TR, and see what that gives me. Because remember, a ratio is the same as a fraction. So the distance QT was root 5. And the distance TR is 3 root 5. Well, hang on, I can go and cancel, because the root 5 would cancel with the root 5. And so therefore, I know that the distance QT over the distance TR is equal to 1/3, and therefore QT is equal to 1/3 of TR, and we've done it. Okay, just make sure I go back to my question. Perfect, QT is 1/3 of TR. Remembering that when we're talking with line segments and we're talking about relationships of line segments, we're talking distance, and so you know that you have to incorporate the distance formula. Okay, that's taken us to the end of question 2. We're going to have a little short break, and when we return after the ad break, we'll look at our question 3, which is the final question of today's segment. See you shortly. Hello there, welcome back. Let's now look at question 3, which is the last question of this particular segment. So, we're looking at, again, an examination past paper question from February 2012, and let's read the information. So I'm going to look and find that there are 3 coordinates on my diagram. A is 1, 4, B is negative 3, 1, and D is 5, negative 2, which is correct. But there's something else that might be important. So let's go and see. They tell me that BD and AD intersect the x-axis at E and F. So BD, where am I? BD, yeah, it's intersecting there at E. And I've got AD is then intersecting at F. That is important, especially because I can see these alphas and betas, and we're talking angle of inclination. So straight away, I'm starting to be aware of how the information is presented in my question, so I can use some of my knowledge and solve some questions. Then they tell me the angle of inclination, BD, with the x-axis is alpha. That's very clear. And remember, the angle of inclination is always what we say measured from the positive x-axis, and we measure it in an anti-clockwise direction. And then beta, also over here, is the angle of inclination. So that was important. They've given that to me. I know it's going to appear in one of the questions that follow. Starting question, always some easy marks to get us into the question. Calculate the gradient of AD. Okay, that's not too difficult. If you don't mind, I'm going to write my answer somewhere on the screen, because when I go down, I keep losing the coordinates. So I'm looking at the gradient of AD, and so I know I'm going to see the change in y, which is going to be y1 minus the other y value, all over the change in x, which then is going to be 1 minus 5. Okay, 4 minus negative 2 is going to give me 6 over negative 4. And please always go simplify. That is negative 3 over 2. The other thing I ask you to do is to look at your diagram, because it's so easy to make sign errors, and I'm prone to making sign errors. So I always look at the actual shape of the line and say, that's a negative gradient. Okay, I'm comfortable with my sign. So just always check your answer and make sure it's consistent with your diagram. Okay, let's go to part 2. Part 2 now says to me, find the coordinates of M, the midpoint of AD. Oh, another nice, easy marks. Okay, and you've got to make sure that these are bankers. We've done midpoint earlier on in the show, so we know that if I'm looking at the midpoint of AD, then it's just the sum of the two x's divided by 2. So I'm going to get 1 plus 5 all over 2. And then I'm going to sum the y's, which then is going to be 4 plus minus 2 all over 2. Let's go simplify. I'm getting 6 over 2, and I'm getting 2 over 2. And so this particular point then is going to be 3, 1. Okay, easy peasy, lemon squeezy. Another 2 marks in the bank. Next question. Here we go. Now what are they asking me? C is a point. So let's just understand over here. C is a point such that the line BC is parallel to AD. Now that is referring to earlier information. So I know that I've found the gradient of AD, and that was negative 3 over 2. So I'm taking my answer from part 1. Okay, so remember, the examiner very often is giving you a lead-in. All those easy questions at the beginning often become very useful later on. When you're doing a question, keep saying, where have I come from? What have I found? How can I use that information? Very important skills. So now, I'm going to go and find C as a point on BC. Well, I actually don't have any C, so I know that C could be here, for example, or it could be somewhere else, but I know that along this particular line, this line is going to be parallel to AD. Well, that's easy, because then I know the gradient of this line, and the gradient of this line is going to be negative 3 over 2, because we are talking about parallel lines. It is the examiner's very clear kind of hint to you when they say the lines are parallel to take the other gradient. You don't have 2 points here to find the gradient BC, but you can use previously found previously found information. Now, let's go and do some work. So I'm going to say the gradient of BC is then equal to the gradient of AD, which is equal to negative 3 over 2. It's always a good idea to tell the examiner why, how you knew that document, and I'm going to say parallel lines or something to that effect. You know, I can even link it and say they told me that they were parallel. And so therefore now my straight line equation is of the form y equals negative 3 over 2x plus c. It's at this stage that you should be doing the same thing every time. You just say to yourself, I'm finding the last unknown. Whether it's C in a straight line, whether it's an A in a parabola, whether it's going to be a Q in a hyperbola, when you're finding the last unknown of any graph equation, find a point on that equation and substitute it in. So I'm trying to find any point that would be along my line. And I just go back and I can find, well, B is negative 3, 1, and I can substitute it in. So I'm going to sub in B, which is negative 3, 1. Put that in place of x and y and go and solve. So the y would be 1, and then I'm going to put a negative 3 over 2 multiplied by negative 3 plus c. We're going to encounter some fractions. It is a little bit ugly, but don't panic. I'm just saying to myself, when I'm multiplying, of course I can use a calculator, but I'm saying fraction times a fraction. Let's multiply tops to tops and the bottoms to bottoms. So I'm going to get 9 over 2. Okay, plus c. And so when I take it over to the other side, it's going to be 1 minus 9 over 2. To make life a little bit easier for myself, I'm going to say, well, that's 2 over 2 minus 9 over 2, which then is going to be negative 7 over 2. And that is what my c value is. And so therefore, the equation of BC is going to be y equals negative 3 over 2x minus 7 over 2. Now, if I stopped there, and my answer is perfect, I would not get full marks. So I hope those of you that are attentive at home and that are reading the question so clearly will be saying, hang on, Mark, there's still another aspect of this question that you haven't answered. There is something that the examiner wanted. And so I'm going to go back to my initial question. And the initial question said, please write the equation in that particular format. Now, you may never have come across this format before. But all that is telling me is we want the x component at the front, then I want the y component and then the constant, but the constant is not in a fraction form. So please just focus on this and look carefully with what I'm doing, because I'm not changing my answer. It's the same equation. I'm changing the form of my answer. It's going to change slightly in terms of how I present the final answer. So at this stage now, even though it's correct, I need to change it. And what I would do to get rid of all the fractions is I would multiply everything by 2. And by multiplying everything by 2, I then get 2y is equal to negative 3x minus 7. And then I must just take everything over to the one side, because they said to me, in the final answer, we want 0 on the right-hand side. So I'm just following an instruction that's been given to me. So take the minus 3x over, so I'm getting 3x, plus 2y, plus 7 is equal to 0. All right, and that now is the final form of my solution for this particular question. Okay, I hope that makes sense, and I hope that you notice that subtlety in the wording of the question. Let's go to our next part. The next part over here now asks me to calculate the size of an angle. Now, this is where you have to have done some work, some learning. You've got to look at your formula sheet and say, I know the formula, I know that we're talking about the angle of inclination, and so I'm going to go and solve there. So let's look at this question. I'm being asked to find this beta. Well, you know that when I play around, that m is equal to the tan of theta. Now, this is on the formula sheet. Now, of course, that this theta will change to beta in the context of this question. But we know that we can always link the angle of inclination to the gradient and vice versa. And in the exam, I can almost guarantee you that you're going to use this. You're either going to be finding out a gradient from the angle, or you'll be finding out an angle from the gradient. So look out for that. And the key words are angle of inclination, or the angle that a line makes with a positive x-axis. That's just taking you back to this formula. So I've got the gradient of AD, so let me remind myself of some information. So the tan of theta, but in this case it will be the tan of beta, because that's the angle that I want, is going to be equal to the gradient. And if I remember correctly, it's the gradient of line AD, which is negative 3 over 2. And that was from part 1 again, gradient of AD. There are many different ways that your teachers might have taught this concept now. Now I'm going to go to my calculator. There are some schools that remove the negative so that you just work with a positive angle and then you take it to the second quadrant. There are other schools that just leave the negative in and then say, well, it's tan. And tan is a general solution of 180, and so you can just keep adding multiples of 180 and that will take you to the angle that we need. But what you need to realize is that because the angle is negative, because the gradient is negative, you know that that angle is obtuse, and so you must end up with an angle more than 90 degrees, and of course less than 180. So let's just see what I'm going to do over here. I'm going to play around. I'm going to say to myself, all right, I'm going to use my calculator, but in order to get to this beta, all right, what I'm going to do is I'm going to say, well, this beta then would mean that I've put this on the calculator. So I've got to find the shift, the arc tan of negative 3 over 2, and that is going to give me some answer. But remember, from a general solution, from our knowledge, from grade 11 onwards, we said that tan just multiplies, it repeats itself periodically every 180 degrees. So let's just see what the calculator gives me. So now I'm going to be doing the shift of tan. Press on your calculator, -3 over 2. Now the calculator is going to give me the equivalent answer. So that answer is -56.3. But you can just add 180 to that right on your screen because you know that tan repeats itself every 180. I'm just going to put -56.3 on the screen so that we can write it down. And I put ... because this is not my final answer and I'm not going to round off. And in actual fact, I don't know how many decimal places. Now, please don't panic because you will always know how many decimal places. I just don't have the front cover. So this, again, is an important exam technique. For every question, always look to see what they've told you in terms of decimal places. If they have not told you in the question, you always refer to the front cover of your examination paper, which I don't have here, and that would have told you to go to 1 or 2 decimal places. I'm going to round to 1 decimal place. Don't crucify me. You know that you would have been able to look at the exam paper, which I can't. So I'm going to take that value. I'm going to now add 180, and that would give me the positive angle, which I'm now going to write as 123.7 because I'm rounding off to 1 decimal place. And if it was 2 decimal places, 123.69. And there I found the angle of inclination. Okay, so please remember this as a very, very important skill. This is the only trick that we really get. When your gradient is negative, your calculator will throw out a negative solution. If you put a negative ratio in, just add 180 to that solution and it gives you the positive angle. Now let's go to the very last part of this question. And this question now says to me, find all the angles in triangle DEF. So I just want to find out triangle DEF. Let's just look closely. And so we're now going to develop some kind of strategy. Well, I know immediately I've got beta. Now, I've forgotten it already, so I just want to go back. Beta was 123.7. So I know that I've got over here 123.7, which means this part in here, okay, that part EFD will be 123.7. So straight away, I'm going to give myself some easy marks. So I'm going to call it EFD. And I'm telling the examiner it's an angle, so I've put that little copy on top there, is 123.7. Again, as I've been trying to emphasize today, give some justification. And so I would just remind the examiner that's because of vertically opposite angles. Because of the vertically opposite angles, I can transfer that angle. Now, my next sort of point of call is to try and find that or that. Hopefully, you realize you only need one of the two. You don't need to find both, even though the question's asking for both, because once you've found one of them, you can use the angles in a triangle, and the fact that they add up to 180, well, then you can find the third. So you're really just trying to look strategically for the two angles, and then the third will just unravel itself. And of course, we now see where alpha comes into play. So you're finding this alpha, and then I know that alpha is going to be on a straight line, so then I can go inside over here. So that means that in order to find the angle of inclination, I need to find the gradient of line BD. So I'm going to go and say, let's find the gradient of BD. And of course, the gradient of BD is the change in y, so it's going to be 1 minus -2. And the change in x, which is -3 minus 5. And so let's just go, that's going to give me 3, -8. This immediately is saying to me negative gradient. Remember, it's going to be obtuse. This is my hint to myself, not what you're writing in the paper. And that's just reminding me, don't forget, Mark, add your 180 if you're getting a negative angle to make life easier. So now I'm going to use my calculator. I definitely can't do that in my head. So I know tan of alpha, the tan of your angle is equal to the gradient. I'm now just transferring the negative to the top. And so I know the alpha is then going to be the shift tan, the arc tan of -3/8. and then I can work out the angle. Right, so let's just all clear. I'm now doing the shift tan, and that's going to be of negative 3/8 get your answer. And for those of you that are thinking ahead, you will notice that this is an important answer, this negative 20.556. But I'm going to go in just the normal way. I'm going to add 180. And so that's going to give me 159.4439. Because I don't have the question, I'm going to round to one decimal place. And so I'm going to give my answer as 159.4. All right? So this answer here is 159.4. But just think carefully. Go back. That's what I found. And I want to go inside my triangle. So I'm going to take 180 off that, or I'm going to take this away from 180. And we'd seen that answer actually present itself on screen. So I'm going to find FED. Therefore, FED is going to be equal to 180 minus 159.4. And what am I going to get? I'm going to get 20.6. And so I'm almost there. I've got two of the three angles. Let's go find the third angle, which then is going to be equal to D. So angle D is just going to be 180 minus the sum of the two previous angles. So what did I get? Oops, 123.7. There we go. Now I found it. Plus 20.6. Okay, I'm going to put that in a calculator. It just looks like there's some nasty fractions. So what have I got? I've got 180 minus, open brackets, 123.7 plus then 20.6. Get to my answer, and that's going to give me 35.7. And so that would then be the final angle, 35.7. I just wanted to let the examiner know why I was doing all of this. So I'm saying this is angles in a triangle, angle sum of triangle, and there I found all three angles. I just want to remind you briefly, this particular question in the matric exam, quite often we could have given this totally unscaffolded. We could have started off by saying, please go and find angle D. And so your approach to any question like this will always be, take the angles of inclination, because that's the only way you can link to angles. Find the gradient, find the angle of inclination, and then always say to yourself, how could you transfer those angles using your knowledge of triangles to then eventually go and get to your angle. Well, that has taken us to the end of segment 1 on analytical geometry. There is going to be another show where we look at some of the circles and some of the more advanced concepts. So stay tuned, keep looking out for that show. That's all that I'm doing in this show, so take care. Goodbye from me, Mark Ancelotti.